Hello friends, and today we discuss actuator example. Basically in this example we use Maxwell in order to develop a complete analysis of simple actuator in 2D cylindrical symmetry. Means our plane is RZ plane. In this actuator example, first we create actuator model. After that we use a Magneto-statics solver for analysis, and we also analyze same model with the help of transient solver. After that we analyze. Okay, so what is a actuator? Basically actuator is a electromagnetic device which can we control the flow of liquid, gas, etc. Okay, start with our experiment. To open the ansys electronic desktop and wait for few seconds. This is our modular window. Start with first step. First step is insert a design. For insert a design, go to Maxwell's, explore Maxwell's. Here design is Maxwell 2D. Select Maxwell 2D, and this is our modular window. This is a X plane and Y plane, and next step is set a solution type. For set a solution type, go to Maxwell 2D, click on solution type. Here already described in our problem, geometrical mode is RZ, so here select cylindrical about Z, and solver is a magnetostatic. Make it OK. Next step is set model unit. For set model unit, go to modular, click on units, select unit make it OK. After the completion of this step, next step is create a model. Here we create a model with the help of line. First minimize the scale. Here we increase the scale up to 10 mm, and here we first draw housing with the help of line. For creation of housing, go to draw and choose line and put the x, y, z value one by one and create a housing. So start with x value is 0, y 0 and z is 0. Make it OK. Again put the value of x is 0, y 0 and z is minus 10. Make it OK. Again put the value of x is 12, x is 12, y 0, z is minus 10, z is minus 10. OK. Again put the value of x is 12, y 0, z is 10. Make it OK. Again put the value of x is 2.5 and y 0 and z is 10. Make it OK. Again put the value of x is 2.5, y 0 and z is 8. Make it OK. Again put the value of x is 10, y 0 and z is 8. Make it OK. Again put the value of x is 10, y 0 and z is minus 8. Make it OK. Again put the value of x is 2, x is 2, y 0 and z is minus 8. Make it OK. Again put the value of x is 2, y0 and z is 0, make it okay. Again put the value of x is 0, y0, z is 0, make it okay. This is our housing. So what is the first step? Go to history tree and double click on polylines and change the name is housing. And assign the material. Here go to materials and edit, choose material is steel 10010 and click on OK and choose the color. Here choose color. Okay, after the completion of this step, what is the next step? Next step is create the anchor. For create the anchor, we use a rectangle. Go to draw and choose rectangle. First put the coordinate of rectangle is x0, y0, and z is 13. Make it okay. Put the value of dx is 2, dy is 0, and dz is minus 8. Make it okay. This is our anchor. And again go to history tree, double click on rectangle 1, change the name is anchor. Name is anchor. Assign same material. Go to edit, select material steel 10010 and choose the color for anchor. Make it okay. This is our anchor. After the completion of anchor, next step is create coil. Here we create a coil. With the help of coil, we magnetize this armature. Okay, for creation of coil, we choose a rectangle again and put the value of x is 3, y is 0, and z is 7. Make it okay. Put the value of dx. Here we put the dimensions of coil. Dx is 6 mm, dy is 0, and dz is minus 14. Make it okay. This is our coil. Here we change the property of coil. Go to history tree, double click on rectangle 1 and rename. Name is coil and assign material. Here we choose a copper material. Copper is a good conductor. Here we choose a copper. Make it okay and assign color. Here coil is completed. After the completion of housing and coil, we define the region. Here we create a simulation region. For create a simulation region, go to draw and click on region. Here padded data, select bullet of pad all direction similarly and put the value of percentage offset. Value is 100%. Hit OK. This is our simulation region. After the completion of this step, next step is assign boundary condition and force parameter. First, select the object region from history tree. Here we create a region. First, select the object region from history tree and go to edit and change the selection mode. Selection mode is edges. Select all three edges. Here we select all three edges and next step is go to Maxwell 2D and search boundaries, assign vector potential, make it OK. Here simulation region is created. After the completion of simulation region, next step is assign force calculation. Here we calculate force on anchor. So here select anchor. First select anchor from history tree and go to Maxwell 2D and search parameter, assign, click on force, make it OK. After the completion of assign boundary calculation and force parameter, next step is assign excitation. Here we assign excitation to the coil. So select coil from history tree and go to Maxwell 2D and search excitation, assign current. Here we apply a 110 ampere current to the coil and reference direction is positive, make it OK. After the completion of excitation, prepare the parametric analysis. For parametric analysis, select just create excitation current 1 and in property window change in property window, open the property window, open the select current and open the property window. This is our property window. Here if don't get property window, go to view and click on properties. Property window is open and here in the property window change the value of current 110 to amp 1. Here value is amp underscore 1 and add variable, click on OK. Here local variable is added. After the completion of this step, prepare for the parametric analysis. Modified the anchor position, select anchor from history tree and in property window change the jet position from 13 mm to 13 mm move select the anchor and open the property window. First select anchor and double click on create rectangle. This is a property window. Here change the Z. Here change the Z position. Here in position replace the 13 by 13 dash move and on OK. Here again add variable, name is move, select type is length, scroll and select length and unit in value is 0, make it OK, click on OK. After the completion of this step, create an analysis setup. For analysis setup, right click on analysis and go to project manager. This is analysis, right click on analysis, click on add solution setup. Here this is our general tab. In general tab, change the maximum number of passes. Maximum number of passes is 16 and percentage, reduce the percentage errors. Percentage error is 0.11 and after the completion of this step, go to solver tab. Change the nonlinear residual is 1e-6 and click on OK and apply validation check. Here all parameter is OK. Here our model is ready to simulate. Close this tab and go to Maxwell 2D and click on analyze all. Save the project is EXP8. Save and wait for some time. Okay, check the messages. Normal completion on server. Okay, fine. After the completion of setup analysis and analysis, after the analyze model, view a solution data. For view solution data, go to Maxwell 2D and search results. Click on solution data. This is our solution data. Check one by one. This is our solution data. This is a force applied on anchor and next step is first close this. Next step is set parametric analysis. For parametric analysis, in project manager, go to project manager. First close the property window and message manager. Go to project manager and right click on Optimetrics and click on add parametric. It's our sweep setup analysis. Here click on add. Here variable is amp. Choose a linear step. Start with 5 ampere and start with 500 ampere and start with 500. Change the value of stop is 2000 ampere and step is 500 and click on add, make it okay. After that set a parametric analysis. Here we set up a sweep analysis window for movement of anchor. Next step is again click on add and change the variable is move. Here choose a linear step, start with 0 mm and stop with 4 mm and choose step size is 1 mm. Click on add, make it okay. After that go to option tab. Here check save field and message and click on OK. The setup sweep analysis is done. After that next step is setting DSO analysis. For DSO analysis, here we activate a DSO solver. Basically DSO is a distributed solver option. For distributed solver option, go to tools and option, click on HPC and analysis option. Here select Maxwell 2D, yes, and click on edit. And here choose the local host and task is 3 core 3 and click on labeled and select local machine and click on OK. Press OK. OK. Here DSO is activated. After the completion of this step, launch the parametric analysis. Okay, for launch a parametric analysis, go to project manager and right click on parametric and click on analyze and wait for some time. Okay, analysis is done here. After the completion of this step, create XY plot. Here plot current versus strengths. For this plot, go to Maxwell 2D and results and search create electrostatic report. Click on rectangular plot and here select X in X. Okay, here choose the force, click on force dot 1 Z, click on none and here in the sweep profile select move and make it okay. After that, go to families tab. Here select sweep, and variable is all, ampere 1 all, and select a new report or new report. Okay, close tab. This is your force, and this is your mm. Okay. This analysis is completed here. After the completion of this experiment, we analyze the same model with the help of transient solver. So first copy this project and paste. This is our pasted model. Okay, here first change the name as you like. Okay, after that next step is go to Maxwell 2D and click on solution type. Geometrical mode is same, cylindrical about jet, but change the solver is transient, make it okay. After the completion of this step, create a band object. Here we create a band object with the help of rectangle. So again go to draw and choose rectangle. Put the coordinate of rectangle is x0, y0, and z is 15. Make it okay. Put the value of dx is 2.5, dy 0, and dz is minus 15. Press enter key. This is our band. Go to history tree and double click on rectangle 1. Change the name is band, and material is vacuum. Leave as it, and assign color. Assign any light color. Band. Make it okay. After the completion of this step, modify the excitation. For modify the excitation, first go to project manager, excitation, and explore excitation, and delete the excitation. Right click and delete. And after that completion of this step, go to Maxwell 2D, go to Maxwell 2D and search excitation. Click on set eddy current effect. Here eddy current effect is calculated on housing and anchor. Click the coil here and click on OK. Again select coil from history, right click on it and search excitation. Assign the coil. Here name is coil, and the number of conductor is 510 conductor, and polarity is sign polarity is positive, and make it okay. After the completion of excitation, modify excitations. and create the windings. Go to Maxwell's, go to project manager and right click on excitation, click on add winding. Winding is winding 1, winding underscore 1, and current type is here type is voltage, and choose conductor standard, and initial current is 0 ampere, and resistance is 2 ohm, and leave inductance value. High voltage is 10, and number of parallel branches is 1. Press OK, and right click on, go to project manager and right click on coil, or click on add to windings, or right click on winding and click on add to coils. Here terminal not assigned the winding, select coil is 510, and press OK. After the completion of this step, assign motion. For assign motion, select band, explore vacuum and select band from history, and go to Maxwell 2D, search model and explore model, motion setup, and assign band. Here motion type is translation, select global Z, and moving back here reference is negative, and go to data tab. In data tab, initial position is 0 mm, negative 0, and positive 4.9 mm. After that, go to mechanical tab. In mechanical tab, click on create mechanical transient. Here initial velocity is 0, mass is 1 gram, and damping is 0, and write down load forces is minus 1000. Put the multiplication symbol here, write down position, and for 1, and unit Newton, and press OK. After the complete of assign motion part, next step is mesh operation. Assign mesh operation on band, select band from history tree, and go to Maxwell 2D. Go to Maxwell 2D, search mesh operations, assign, inside section, click on length based. Here name is change the name, name is band, and underscore length enabled, and set maximum length of element is 0.1 mm, and uncheck maximum number of additional element and make it okay. Okay, and next step is create analysis setup. For analysis setup, here after the completion of mesh operation in band, we apply for housing and anchor also. First select housing and anchor from history tree, and go to Maxwell 2D and search mesh operations, assign, inside section, length based. Here change the name is steel, underscore length 1, and length, set the maximum length element is 1 mm, and uncheck maximum number of additional elements, make it okay. After the completion of this step, create analysis setup, go to Maxwell 2D and click on analysis setup, add solution setup. Here in general tab, put the stop time is 20 millisecond, and put the time step is 0.2 millisecond, and go to save field tab. Here save field tab, sweep setup type is a linear step, choose the linear step and start with 0 millisecond and stop time is 20 millisecond, and step size is 0.2 millisecond, and click on add to list, and after that go to solver tab. In solver tab on linear residual is 1e or n1e minus 6, and click on OK. And apply validation check. Here all parameter is correct. Close this tab and go to Maxwell 2D, click on analyze all, wait for some time. Okay, check message window, normal analysis done, and after the completion of analysis, next step is create a mesh. So plot meshes. For plot meshes, go to view and click on set solution context, and select time and press OK, and go to edit and click select all, and go to Maxwell 2D, fields, click on plot meshes, done. This is your mesh plot. After the completion of mesh plot, plot the flux lines. First remove the mesh plot. For remove the mesh plot, go to project manager, explore field overlays, right click on this and select delete as, and again repeat the same. Go to edit and click on select all, and again go to Maxwell 2D, search field A, flux lines, okay, flux lines plot, press done. This is your flux line plot. After the completion of flux line plot, plot magnetic flux density magnitude. First remove the flux line plot from project manager, right click on field overlays and explore field overlays, and right click on delete, yes, and again edit, click on select all, go to Maxwell 2D, fields B magnitude, done. This is your flux density plot. After the completion of flux density plot, plot force versus time, rectangular plot. For rectangular plot, go to project manager and right click on result and click on create transient report, select rectangular plot, select force, here domain is sweep and parameter is none, select force, here select moving force 1 and moving force load force, and click on new report, okay. This is a method which can help me plot plots. So this workshop is completed here. Thank you.